Hello, this is Introduction to User Interface of Microscopy Image Browser. The program has three main parts: a menu, a toolbar, and the panels. Let's start with the panels. The first panel in the top of the screen is called Path panel, and it allows to define a directory where the data is stored. For example, we can go in this combo box and then select the logical drive, which we would like to check. The updated list of directories and files is shown in this directory contents list box. It is also possible to define a directory using this button that starts the standard directory selection dialog, or by typing a directory name directly into this edit box. So the directories that are shown in this list box are indicated with the square brackets, and the actual data files without those. By default, the program can open number of standard image formats as well as few additional image formats, such as, for example, a mirror mesh. It is also possible to extend to use the by formats reader, and in this case the number of formats is extended, and it is possible to open number of microscopy image number of different microscopy formats. When we double click on a directory, we go inside of that directory, and then if we double click on the file, we open the selected file and then can see it in the image view panel. It is possible to have up to 8 datasets opened simultaneously. In order to open another dataset, for example, we select an empty container, for example number 5, then we go with directory, and then within this directory we can go and select files that we want to open, for example using a Ctrl or Shift button. Now I used a Shift and mouse click to select the files, and now I can press the right mouse button in order to start a pop-up menu. This pop-up menu allows to define number of different actions with selected files. For example, I can combine these files into a stack. So you can see that all these files that I have in this folder are now combined in one dataset. By clicking with the left mouse button on these buttons, I can swap between these two open datasets. In order to remove this dataset, I have to select this dataset first, then press the right mouse button and clear dataset. Let's try to open one of the light microscopy datasets. For example, using the by formats, I can open leaf format which comes from Leica. When I double click on this file name, it opens a dialog that asks for which of these datasets that are stored within this leaf file I would like to open. I select one or several of those and press continue button. After that, you can see that I opened the dataset, and I can check and see how it looks like. This dataset has two channels. In addition, the dataset comes with different parameters that may be checked using the info button. Some of the panels are fixed, such as, for example, path or directory contents panel, but there are two panels that may be changed. One of the panels is the segmentation, and it's possible to swap it with arrow eye panel by using this combo box. Another panel in here, it may be changed, and then depending on what kind of work is done, it's possible to select number of different panels. Now I'll try to open SV dataset, and then I have, for example, 3 images here, and then I'll try to combine them all in one stack in order to see them fast. I've opened the images, and then you can see they are quite dim because the actual intensities are quite low for 2 channels. Let's try to improve that. The easiest option is to go to the view setting panel and click on fly mode. The on fly mode takes the image which is shown on the screen and adjusts the contrast so that it stretches the whole image to see it better. And what is important here is that it automatically that the image that is stretched taken from the image which you see on the screen. So now it uses the data which is only the data we see at the moment. And for example, if I move to the areas that have no cells, I will amplify my noise and see the noise very nicely. Then when I move the mouse above the image, I can see the coordinates of the mouse in the pixel info field in the path panel, but I can also see the intensities which are shown in these 3 fields here. The open data files are indicated in the title of the panel, and when I scroll through the dataset, I can see that actually this is my first file, flag actin IPO number 1, then 2 and 3. It is possible to use alternative way to enhance the contrast, and for that you can press the display button. Display button starts the adjust display dialog. This dialog allows you to select a color channel which you want to adjust, for example color channel 1, and then you can use these sliders in order to stretch the contrast for the data. The upper slider for the minimum intensity and the lower slider for the upper intensity. It's also possible to adjust this by just using the mouse button. When I press the right mouse button defines the right edge of the histogram, and the left mouse button defines the left edge of the histogram. There are 2 buttons that are called min and max. When pressed, the program automatically finds the minimum intensity point and then stretch the data so that this minimum intensity point becomes black and the maximum intensity point becomes white. So we did it now for the color channel 1, and then we repeat this for the color channel 2. And then if we can quite easily see the data. You can also recalculate the intensities by pressing this adjust channel 2 button. This may be quite handy if you want to convert the dataset to the 8-bit format. Well, let's try that. So I'll press adjust channel 2, and then what happened, it recalculated intensity, and then they now from 0 to 65,000. And then I'll do the same for channel 1. Now the data is stretched, and then I can go and convert the image to 8-bit format. This is done via menu, mode, image, menu, image, mode, 8-bit. When I press this button, it will convert the data to 8-bit format. Now the data is 8-bit, which is indicated by the numbers here. So they are all below 255. Now the color channels that we see here, they are encoded in the red and green, but it is also possible to put the custom colors. For example, I know that my first channel comes from DAPI, so it should be blue. In order to do that, I need to press this LUT checkbox, and when it is pressed, I can define any colors I like. For example, if I click on this red square here, it starts a color selection tool that offers me possibility to define any color I like. I can set it to blue. And then the other color I can set, for example, keep it on green, or I can set it at this red channel. and this allows me to use the colors that are actually the correspond to the color channels of the actual data. Then in the next panel here we can perform some different filtering routines. For example, we can perform a Gaussian filter, and the channel that we want to use for the Gaussian filter is defined in the selection panel. So for example, I can do a Gaussian filter for channel 1, which is a blue channel. Let's put a higher sigma. So you can see that the blue channel was smoothed. I can undo this by pressing Ctrl Z button. If I just continue pressing Ctrl Z, I can swap between my result of my filter and the previous state. If I want to go further in history, I can use the two buttons in the toolbar. If I want to filter second channel, then I select the second channel and press the filter, and then you can see that the first channel was intact. I can also filter both channels, and this color channel dialog combo box shows all. All actions that are done with datasets are stored, and it is possible to see what has happened with the dataset by pressing the log button in the path panel. For example, in this dataset you can see that we've done already a number of actions. For example, we stretched the contrast for 2 channels, then we converted the image from 16-bit to 8-bit format, and then we applied twice the Gaussian filter. It is possible to add some field. For example, I can add something test and remove. I can modify, and then I can delete the entry. The log file is stored with the data, and it is possible to restore it if data is stored in a mirror mesh and TIFF formats. So for example, we have this data set, we can save it file, save image as, we can select TIFF, let's call it like flag, temp, save. When the data is saved, the program asks for the voxel size, but we can leave it as it is now. And then we can also save data as 3D TIFF or sequence of 2D TIFF files. Let's save it as 3D TIFF. So now it's saved, and then we can see file here. If I just open it in the next, I should use the normal opener, and then I can check the log, and then I can see that all data is preserved. In addition, it got this field which is bounding box, and this is calculated from the voxel size. Okay. Now I will open the dataset from scanning electron microscopy. Now it is shown it is a single channel, but it's shown in blue because we still have this LUT checkbox checked. So I will uncheck it, and then now it's grayscale. I can also, of course, I can make it seen in this kind of in the grayscale if I select the black color here. Oh, sorry, white color. So we can scroll the dataset using the mouse wheel, and when I use the mouse wheel with the shift key pressed, I can jump by 10 slices, and it is possible to set the step. If you right click on the slider, it's possible to set a step for each slider iteration. Let's take a look on the toolbar. So toolbar has a number of buttons that allow fast access to certain actions. For example, the first button is open file, but it's more like used to import file from Matlab workspace. The second one is the save model. We don't have any model yet, so we can't really do that. Then another button is for developmental purposes. The next set of buttons are defined in order to magnify image, which is in a way similar to use of W button, or set the image 1:1, pixels on the screen to pixels of the dataset, stretch to image axis, and then zoom out, which is similar to Q button. The next button, which looks like a hand, defines the way how the pen mode works. For the bigger images, there may be a lag between when you press the mouse button and then the moment when you actually can start moving the image around. If you press this button, there will be no lag, but you do not see the image when you actually move your dataset within the image axis. And then only when you release the button, the data is shown. The next two buttons allow to perform go-in steps, in history steps for undo and redo. The next is the movie player and the snapshot tool. The snapshot tool allows to make a snapshot of the image which you see in the screen, and it's possible to define number of different options, such as make snapshot for clipboard, and define whether you want to create a snapshot of the whole image or only the image which is shown within this viewing window. Define the size, define the resizing method, and there is an option whether to add or not a scale bar. The next three buttons offer possibility to check the dataset in a different dimension. Now they look at dataset in the XY, but we can also check it in ZX, where the Z is here, X here, or ZY. There are also three shortcuts that duplicate these buttons, and they work a little bit more advanced than just by pressing this button. So what I will just show you, I will create a small circle, a small ball within this Lipin droplet, and then now if I press Alt 2 to switch the orientation to ZX orientation, what would happen that my mouse will be placed in the center of this at the center of this sphere that we just drawn. And the same way again, if I just keep it here and then press Alt 3, then I change the orientation to ZY mode, and then the cursor would actually indicate me the position which I had correspond to the position in the previous orientation, and that's switch back to XY by pressing Alt 1. So this is quite handy in a way if you want to follow what exactly in the dataset you will end up when you change the orientation. The next tool is the measuring tool, so it is possible to measure a distance. Then the distance is the line that was measured is indicated in a green color, and it is selection layer. In order to remove it, one have to press the C button here in the selection panel, C, or press the C button on the keyboard, which is a shortcut. The next tool offers a different way of shaping or line interpolation, which will be explained later in the segmentation tutorial. The other tool offers the possibility to work with the shown part of the dataset only. So for example, if I zoom in to a certain part of the dataset and I would like to filter this area, filter it only the one which was within the viewing axis. It allows perform some of the actions in 3D, for example, for some fast checks of certain filters, because I can always undo the result by pressing Ctrl Z. If we have arrow eyes, then we can also switch them on and off using this button. And the last two buttons offer possibility to swap left and right mouse button. So for example, now the right mouse button offers the possibility to move the window around, and the left mouse button may be used for drawing. Also, the mouse wheel in the default state offers possibility to change the slices, and the QW may be used to zoom in, zoom out. It's possible also to change this. In this case, when this button is unpressed, if I move the mouse wheel, I actually do zoom in, zoom out, and the changing of the slice is done using Q and W buttons, which can also be used with Shift. Jump for larger steps. Then the menu. There are a number of entries in the menu that actually repeat some of the buttons that I have in the panels, but there are a few others that are not there. So let's take a brief look on those. So for example, we can import data from the Matlab workspace. For example, if I take this image which I have now, I can export it to Matlab, and the window appears that asks me for the variable name. Let's call it I. If I start Matlab now, I can see that I created I variable and IInfo variables in Matlab. Now I can check my image. So this shows my first slice of my dataset, which I have in Microscopy Image Browser. I have it in Matlab. So if I have this kind of data in Matlab, I can import it back to Microscopy Image Browser. For example, I can invert the image, I equal minus I, and then I can send it back, file, import I, and then I will also take the corresponding metadata, and then you can see that the image is inverted. Then we can also save image as, and then there are a number of formats that may be used. I usually, for all my data, I use the mirror mesh format because it's fast and reliable, and then if I need, I can always convert it to TIFF. We can make a movie. In this case, there is again this a dialog appears which allows you to define such things like a codec, directory, and the quality and the size of the movie which you want to create. Make a snapshot. I can also render the volume using the Fiji 3D viewer, and just use the default parameters. And then you can see that the Matlab starts the image J, Fiji, and then in here you can see the actual volume that we have now in opened here. So it can be possible to check and see how it looks like. The only thing we may need to adjust the threshold in order to remove the voxels that are it's a little bit slow. Okay. Oops. Not transparency, but adjust threshold. Okay. For some reasons it looks quite slow now, maybe because of the screen grabber. And then the last entry here is the preferences. And the preference is the way how you define menu steps in Microscopy Image Browser. For example, you can define the behavior of mouse wheel and the left mouse button. You can set the image resize method. Now it's bicubic, but it's possible to set it to nearest. Then there's a number of steps for the undo history. So currently there are 8 steps remembered, and 3 of those are 3D steps. Then also set the setting for the interpolation, and define number of materials in the model. The default option of 63 allows to save memory, but then if you need more, then that's another option. So I recommend to use 63 all the time. The colors may be also defined for the materials of the model. Then you can just type the whatever, any number here you like, or you can click on this square to it's in the back to define a color, any color you like. The similar for the colors for this look up table, and colors for mask and selection. It's also possible to modify the font size of the program. Then the next entry in menu is called dataset, and offers the possibility to align the dataset. For example, it's possible to align the current dataset, which is a little bit slow but still works, or it's possible to align the two datasets which are from the disk, and it's pretty powerful tool. Then we can crop a dataset. For example, we can crop dataset using interactive mode. In this case, if I press continue, I can just draw with the left mouse button a rectangular, and then the data will be cropped to that area. I can also use the manual mode when I define these numbers myself, or I can get the area from ARY to crop with. For example, if I have ARY, I can add an ARY, which is this rectangular. There's a number of different shapes for AROIs. In order to change the shape of AROIs, I have to press the modify AROI button, and then I can, for example, I want to crop to this mitochondria. I can go to dataset, crop dataset, from AROI, select AROI I like, and press continue. And then the data gonna be cropped to this AROI which I have selected. Resample is changing the size of this dataset. There are a number of options. There is also possibility to transform dataset in different orientation, and it is possible to delete a slice or number of slices from the dataset. Then we can define the bounding box, such as, for example, the shifts of the bounding box and its coordinates. It's possible to set the parameters. So now the voxel size are 1313.03, which means that when we look the dataset in ZX dimension, it properly stretched. In the image menu, there is possibility to change the type of the data and change the color, color mode. Then we can do some actions with the color channel, such as, for example, swap, invert, copy, delete, which is actually also available from this table. If I press the right mouse button, I can also get the number of possible actions. Then we can adjust the contrast using different options. Then we can invert the image. Then we can do a few filters such as top hat and bottom hat filtering. We can draw intensity profile and histogram. Then model, mask, and selection. These are the three menu entries that are designed for modeling. I want to talk about them now. And then there is also some tools and the plugins, and then the help. I think that's it for beginning.